All right, so in example 2.23, we're talking about finding the angle between two vectors. All right, so let's find the measure between each pair. In the first problem, we're given our standard unit vectors, I plus j plus k, and 2i minus j minus 3k. All right, so using the rule up above, to find the angle, we know that cosine of the angle is equal to u dot v divided by the magnitude of u times the magnitude of v. So we need to calculate u dotted with v, the magnitude of u, and the magnitude of v. So we can do this all at once or in 3 separate steps. I think I'm going to do them separately to start off with. All right, so for the first one, u dotted with v, that means that we're interested in the dot product of this vector and that vector. So multiplying the components, 1 times 2 are our I components, plus 1 times negative 1 are our j components, and then 1 times negative 3 is our k component. So u dotted with v is negative 2. Okay, next let's calculate the magnitude of the first vector. So that means I'm taking 1 squared plus 1 squared plus 1 squared and placing all that inside the square root. So we're getting the square root of 3. And finally, the magnitude of our second vector, 2i minus j minus 3k. So I've got then the square root of 2 squared plus negative 1 squared plus negative 3 squared, which is the square root of 4 plus 1 plus 9, or the square root of 14. So putting it all together, we get that cosine of the angle between them is going to be negative 2 divided by the square root of 42. So I think what I'll do now then is, well, there's realistically a couple different ways. You can actually leave it just like this, especially because this isn't going to give us a very nice answer. So this is an exact value instead of a decimal approximation. So I think for simplicity, I might actually just leave it just like that, and we'll kind of see what the solution does when we're done. Right. So for the second one, we're interested in the vectors 2, 5, and 6, and the vector with components negative 2, negative 4, and 4. So once again, we know that cosine of the angle is the dot product divided by the magnitude of each individual vector. All right, so let's take care of this computation. To do the dot product, we want to make sure we're multiplying the components. So the first component, 2 times negative 2, is going to give us negative 4. The second component is 5 times negative 4, so that's going to give us negative 20. And the third component is 6 times 4, so that's going to give us 24. Divided by, well, this is certainly going to be positive. So the reason I've kind of taken pause here and haven't calculated anything is because I've noticed that my numerator is actually going to equal 0. So if cosine of the angle is equal to 0, then what that means is that our angle is equal to pi over 2, or 90 degrees. Wow, 90 degrees. So these two are orthogonal. All right, so let's take a look at the solutions and see what they did. So they did the same thing. They left it in terms of our cosine, so that's fine. They found that value of 0, got pi over 2, and we're done. Fantastic. So I'll encourage you, as usual, to take care of the checkpoint on your own. So for the checkpoint, we are interested in finding the measure of the angle in radians, we're told, formed by the vectors A, which has components 1, 2, 0, and B, which has components 2, 4, 1. And round to the nearest hundredth. So this time we're told explicitly to actually round. All right. So go ahead, pause here, and give it a shot.